Okay, so we're going to talk about systems of equations, and that's what we're talking about this week and next week. So today we're graphing. Today and tomorrow are the only graphic days. And then after that, no more graphic for this unit. So that's kind of nice. So let's talk about what a system of equations is, first of all. You probably saw some of this on your PSAT packet when they just give you those two equations together. That's all a system of equations is. Okay, so if I was going to give you just like an example, something that looks like this. So it's two equations together, and here I have x's and y's. You can have three equations, so like it could have an x, a y, and a z, and we'll do that, I think it's like next week maybe, when we do the three variables. Okay, we're going to stick with just x and y right now. So you probably have seen this in algebra 1, hopefully. So when we're talking about systems of equations, we're going to always find the solution, figure out what the solution is. Sometimes, though, they want you to verify a solution. Okay, and when you verify a solution, it has to work for both equations. So we're going to do this. We're going to verify the solution on our first example. So number 1, so this is what they're going to give you this. They're going to give you the point 2,4, and they're going to give you a system of equations. X minus 2y equals -6, 2x plus y. So I'm going to box that so you know what you're given. So they're saying that here's your system of equations. They want to know, is that coordinate point a solution of the two equations? So how would you determine that? Plug it in, that's it. So underneath here, I'm going to write, I'll write the equation first. X minus 2y equals -6. We'll just start with the first one. So I'm just plugging in this x and this y into this equation. So I have 2 minus 2 times 4 equals -6. Okay, you can put this side in your calculator if you want. You would get -6 equals -6. That's all I want to see on your paper. I want to see you plug it in, and I want you to show me that, yes, they do equal each other. If it works in the first equation, I have to still go and plug it into the second equation, because we need to make sure that it works in both. So this would be 2 times 2 plus 4 equals 8. Again, you can plug this left side into your calculator if you want, but I want to see at least that much, and I want to see 8 equals 8. So is 2,4 a solution? Yes, it works in both equations, so I'll just say 2,4 is a solution. The main thing is make sure you check it in both. If it works in one, it has to work on the other. If it doesn't work in one, it might work on the other, and it might not work on the other. Okay, let's do one more of those. So they'll give you 5, 3 is the coordinate point. There's what they give you. So go ahead and plug it into the first equation and see if it works. So 6 times 5 minus 7 times 3 equals 1. 3 minus 21. So you should get 9 on the left side and 1 on the right side. So do I need to check this point in the other equation? No, if it doesn't work in this one, it doesn't matter about the second one. So I'm just going to say 5, 3 is not a solution. So this is working backwards. Everything else will work forwards. We're going to find what that solution is. In this case, they give it to you and they want to know, is it a solution or not? Okay, so the next thing is we're going to classify systems. We have 3 ways to classify systems of equations. So 3 types of systems. So I'm going to draw 3 little x, y coordinate planes so we can classify by the pictures and then also give you all the names of them. So make sure you write this down correctly because you don't want to miss this on the quiz because you wrote it down wrong. But then for the test, you will have to memorize the names of them. Okay, so for the first one, I'm just going to draw 2 lines. Doesn't matter what you draw, I just want them to cross at one point. So just 2 lines. So because our system has 2 equations in it, this one, since they cross at one point, there's one solution here. And that solution would be whatever that coordinate point is. So when we graph them, that's what we're going to look for, is what is that solution. So one solution, we call this an independent system because each line is its own thing. They're completely separate, independent. And they also use the word consistent, just meaning there is a solution to the system of equations. So one solution, independent, consistent. Okay, the second one, I'm going to draw one here in purple. And then I'm going to draw a green one going over the purple one. So the first one here, they touched one time, there was one solution. How many times are these lines touching? Multiple times or infinite times. So this is infinite solutions. Infinite solutions. And instead of independent, we say dependent. But also still consistent. Because there are solutions to the system of equations, there's just a lot of them. So dependent and consistent. So I have one solution, infinite solutions. What do you think this one's going to be? No solutions. What kind of lines create no solution, do you think? Parallel. Perfect. Parallel. So this would be no solution. And we just say this is inconsistent because there's just no solution to it anytime. So it just has one word, inconsistent. Okay, so we're going to do 2 examples where we're just going to classify the system. So when I say classifying, I just mean this right here, and then determining the number of solutions. So this is what your directions would say, like on a quiz or test. Classify the system. And determine the number of solutions. And it all goes together. If you classify it as independent and consistent, then it's one solution. So they just want to know which set is it. So number 1, I'm going to give you the system first. So if I want to look at these lines, the main thing I want to look for is the slope. Okay, so how do I look at the slope of this first line? What do I have to do to it? Put it in y equals mx plus b form. Okay, so I need to get y by itself. So some of you who are having trouble getting y by itself, this is good practice. Okay, so when you're doing this, I like to do a number 1 and a number 2 equation. Okay, because when, especially with me looking at your work, I can go and see what did you do when you're graphing, where's your number 1 equation. So I want to get the y by itself. How would I get y by itself right here? Perfect. Subtract the 7x. So I have y equals, and put it in order, negative 7x plus 13. So there's my first equation. Do the same thing with the second one. I want to get y by itself. So what would you do to get y by itself? The 28x over. So subtract 28x. 4y equals negative 28x minus 12. Yep, and when you divide by 4, I want to see this. I want to see you divide by 4 here and on all of these pieces over here. Okay, some of you are forgetting to do this part, and it's going to mess up your graphs. So y equals negative 7x minus 3. So when you look at these two equations, what's the first thing we want to look at? Slope. So I have negative 7 and negative 7. Any ideas as what this might be? No solution. So up here, I'm going to go back up here for 1 second. And under this one here, no solution, I want to write different slopes. Sorry, I forgot to say different slopes. Oh no. That is same slopes. That's my brain. That was wrong. Same slopes. Different y-intercept, what I wanted to say. And I'll zoom in a little bit. So on your no solution one, just under inconsistent, I put same slopes, different y-intercepts. What do you think we're going to look for on this one here in the middle? Everything is the same. So I'm going to say same equation. And then on this one, what's nice here is you're just looking for different slopes. Okay, so back down here on this one, we said there are same slopes, so I heard you guys say no solution, and then we would classify it as inconsistent. The far right, this one is same slopes, different y-intercept. Oh, I'm sorry. I went backwards. I don't know why. I guess I would have went from the example. Okay, let's do one more like that, and then we'll do a couple of graphs. So number 2. So I want you to go ahead and work on getting y by itself on this one, and then see if you can classify it. Inconsistent, and then we said no solution. you finish up, you can check your equations with mine. Questions? Okay, I'll let somebody finish. Those of you who are done, we're going to go to the graphing page next. We're going to take that out. Okay, so we're going to do the same thing on the graphing, except you'll actually graph the line and find the solution. I'll probably just do 3 of these because you guys have done a lot of graphing in the last minute. Okay, so number 1, let's do the same thing and label our 2 equations, 1 and 2. Okay, just like before, I want to still get it in y equals mx plus b form. I can't graph it until it looks like this. Okay, so the first equation, I'm going to rewrite that because it's not in slope-intercept form. So I want to say y equals negative x plus 3. This is what I'll look for. I'm going to look for your equation first, make sure you got your equation right, and then I'll check your graph. Okay, so let's go ahead and graph that one. Where do I start at when I'm graphing? 3 on which axis? X or y? The y. So positive 3 on the y-axis. And what's my slope? Negative 1 over 1. So I go down 1 over 1 each time. And then up 1, left 1. And I'm going to put a little 1 there so I remember which equation is which. Okay, and the second equation, we need to get y by itself. So 6x plus 2y equals 2. What's the first thing you do to get y by itself?
Subtract.
Good. Subtract 6x. So that's gone. 2y equals negative 6x plus 2. Perfect. Divide by 2 on everything. So y equals negative 3x plus 1. And I'll box that. It's going to make your life easier if you do this and label it number 1, do the work, number 2, do the work, and then graph that. So on this one, I start at positive 1. On the y-axis, remember, what's our slope? Down 3, right 1. Be careful with your slope because you're looking to see where they cross at. So like as soon as I went up to your left one, I see they cross right there. So if they cross, you tell me what that point is. So that point is negative 1, what's that, 4? And then I would go ahead and classify it so you get practice in on doing this. There's one solution that's an independent, consistent solution, or consistent system, sorry. Okay, so I gave the solution, independent, consistent. You can verify this by plugging it in just like we did at the beginning. It should work in this one, and it should work in this one. If it doesn't, something went wrong. Let's go down to number 3. Anyone still working on number 1? Okay. you're on number 3, go ahead and get y by itself. And then you can start graphing if you want. You're going to wait on a few people. Okay, so number 3. Equation 1, equation 2. So I'm on number 3, I skipped number 2. And this is a good one because some of you, we had this on either a quiz or a test where you had an x over here, and when you divide, some of you were confused by what that slope was. So what is the slope here in front of the x? 1/5. Good. 1/5 x minus 2. So I'm going to go ahead and graph that. Make sure you start at -2. And then I go up 1/5. Okay, and then the second equation. We don't usually see them like this. I have the y and I have a number over here. So how do I solve for x? Do I do the 3 first or divide by 5 first? The 3, good. Move the 3 over. So 5y equals x plus 3. So it's just the same as the x, except it's just a number. And now divide by 5. Let's see. Correct. So you should be able, because we just did these without graphing, you should be able to see what they're going to look like before you graph it. And if you notice, the slopes are the same, but they have different y-intercepts. Okay, but you still need to graph both lines. I'm going to look at that. So starting at 3/5, just start in between 0 and 1 is all you have to do. And then up 1, just go halfway in between again and over 5. Okay, so you should see that, oh, they're going to be parallel lines, which means I have no solution. And what's our classification for that? Inconsistent. Good. No solution and inconsistent. We're going to do that last one together. That first equation on number 4 is already done for you, so go ahead and graph that if you're done with number 3. So I graph the first line, and then the second one I have to get y by itself. So I'm going to subtract over the 12x. And divide by 3 on everything. What do you notice about these two equations? They are the same. So It doesn't matter over here if you want to do like a number 1 and a number 2 because it's both of them. If you want to do 2 different colors, or you can just graph one line. It doesn't matter because then down here I'll know that you know it's the same line because we're going to say infinite solutions and classify that as dependent and consistent. Okay, but I still want to see your work. So I'm going to look to see that you have your 2 equations. And then this part here, infinite solutions, dependent, and consistent. So if you need help remembering that, consistent just means there is a solution. So whether it's one or many, it's consistent. Dependent, think about things that depend on each other, and those lines are the same. Like they're just literally sitting on top of each other.